Welcome. Today we discuss the chapter Properties of Triangle and Height and Distance. A very important chapter in trigonometry. Today we discuss its first part. Like other trigonometric chapters, this chapter also contains a large number of formulas, and actually we have to keep in mind for answering quickly the problems given in question. So first few basic formulas I think you know. One is sine formula. Sine formula is A by sine A. Before that, you know it well, still I say any triangle has 6 parts, 3 sides and 3 angles. Suppose this is a triangle, it is A, B, C. 3 sides and 3 angles are there. A opposite to capital A, vertex capital A, this side is A, this is small b, this is small c. That angle is capital A, capital B and capital C. So first of all, I tell you that sine formula is A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R. A small ABC, capital ABC I explained just now, and 2R, but R is the radius of the circle circumscribing that triangle ABC, that is circle passing through A, vertex B and vertex C. This is a circle, its radius is R, 2R is diameter. We have to use this formula very frequently. So then cosine formula. Cosine formula is just now A by sine A is equal to 2R. Cos formula is cos of the angle A, it is equal to B square plus C square minus A square by 2BC. That is, it is related with 3 sides A, B, C in one side and other side one angle capital A. Similarly, it has 2 other cosine formula. Cos B, for cos A square is negative, other 2 positive. Similarly, cos B, cos C can be obtained. Next one, projection formula. Projection formula is side small a, it is equal to B cos C plus small c cos B. A, B and C, 3 sides are involved here and 2 angles, capital B and capital C. Similarly, B, small b, it can be expressed in terms of small a and small c, capital A and capital C. That is C cos of A plus A cos of C. Similarly, there is another formula, small c. I'm not mentioning it. The next one is tangent formula, tangent rule. It is tan of B minus C divided by 2 is equal to small b minus small c by 2 into cot of A by 2. Similarly, it has other two rules. Here also, capital A, capital B, capital C, all three angles are involved, and small b and small c, these two sides are involved. Next one is half angle formula. Half angle formula, which is sine of a by 2 is equal to a is the angle, a by 2 is half angle. Its sine formula is root over of s minus b into s minus c by s by b into c. Similarly, sine b by 2, it will be root over of s minus c into s minus a by ca, and sine c by 2 also. Cos, for cos, half angle cos formula, cos a by 2, it is equal to root over of s into s minus a divided by bc. Cos a by 2. Cos b by 2, another formula. Cos c by 2, another formula. And combining these two, there is one more formula, tan of a by 2, this by that is bc cancels, root over of s minus b, s minus c, sorry, root over of s minus b, s minus c divided by s into s minus a. Similarly, tan b by 2, tan c by 2, other formulas. The next formula is relating with area of the triangle. Normally, area of triangle is denoted by delta. Delta is equal to half B C into sine A. Number one, same formula, half of CA sine B. Another formula is there, like there, the half of AB into sine C. Next, one well-known formula, root over of S minus A, S minus B, S minus C. So ABC we know, capital S, this capital S, it is equal to semi-perimeter, means S is equal to A plus B plus C by 2. Next one is in radius. Now let us see what is in radius. Any triangle, one circle can be drawn touching all these three sides internally. This circle is known as, sorry, suppose this circle is in circle of this triangle. Its radius from this to that or this to that, this is called in radius of the triangle ABC, and its radius, in radius R, is equal to delta by S. Delta is area, you can use any formula, and S is semi-perimeter. Next, X radius. Consider this triangle extend this side and that side. This is not extended, and this one is extended, that one is extended. It is a triangle is ABC. Now, one circle can always be constructed touching this straight line, this extended side, that extended side. That is like that. This is one X circle, and it is normally R1. R1 means first side. If capital A is the vertex, one vertex, first vertex, then this is not extended, other two are extended, then it is called R1. And R1 is equal to delta by S minus A. Similarly, other two X radius is delta by S minus B, delta by S minus C, and so on. Last of all, I discuss a relation between circumcenter, centroid, and orthocenter of any triangle. Circumcenter for any triangle. Suppose this is a triangle, a circle which circumscribes this triangle, that is passing through the three vertices A, B, and C. This is called circumcircle, and its center is circumcenter. If it is circumcenter, clearly this is a radius, this is another radius, this is another radius. For circumcenter O, OA is equal to OB is equal to OC. Next, centroid, you know, centroid, point of intersection of three medians, normally called G, and orthocenter, it is the, if perpendiculars are drawn from vertex to opposite side, then these three perpendiculars will meet at a point, and that point normally is denoted by O dash. O dash is orthocenter of the triangle. One very important thing is that if a circle is right angled, ABC, B is the B, this angle B is 90 degree, then the B, this vertex is orthocenter of the triangle, because from this perpendicular is drawn opposite side, which is AB. From this perpendicular is drawn on AB is CB. So two perpendiculars meet at the point B, and from B, so you see, this is the orthocenter of a right angle triangle, and orthocenter is the vertex containing 90 degree, containing right angle. So what I told you here, the O circumcenter, G centroid, and O dash, for any triangle, these 3 points will be collinear always, and G divides O dash, G divides O dash internally in the ratio 1:2. So this point is, say, if it is O, it is O dash, this is G. G divides O dash internally in the ratio 1:2. It is very, very important point for competitive exam. Two points will be given, O and O dash, say find G, or O and G given, find O dash, and so on. If you know the formula, answer is very simple. Okay, so now we take some problems. If some other formula is there, I discuss at that time. First problem. In triangle ABC, if 2 cos A by A plus cos B by B plus 2 cos C by C is equal to A by BC plus B by AC. In any triangle ABC, in the triangle ABC, if this is the case situation, this is equal to that and that, then angle A is how much? Number 1, 60 degree, 45 degree, 120 degree, and 90 degree. If this is the situation in a triangle, then capital A, that is angle A, is how much? This is the question. Simply you put formula of cos A, cos B, and cos C. So it is equal to 2. Cos A means B square plus C square minus A square by 2 BC, and 1A is there, plus cos B is A square plus C square minus B square by 2 AC, and 1B is there, plus for that 2, here is 2, there also 2, but no 2 is there, mind that. It is 2 A square plus B square minus C square by 2 AB, and C is there, is equal to, in this case, it is A square by ABC plus B square by ABC, that is A square plus B square by ABC. Now we can cancel ABC throughout. ABC, this ABC, this ABC, so that we get a 2 cancels here, B square plus C square minus A square plus A square plus C square minus B square by 2, plus there also 2 cancels, A square plus B square minus C square is equal to A square plus B square. Now multiply by 2, so that it is equal to 2B square plus 2C square minus 2A square plus 2A square, 2C square is equal to 2A square plus 2B square. Now 2A square cancels, 2B square cancels, 2C square cancels. Now thing left, they together is B square plus C square minus A square is equal to 0. That is, B square plus C square is equal to A square. So B square plus C square is equal to A square means either we can say that cos A is equal to B square plus C square minus A square by 2BC. B square plus C square is equal to A square, it means it is 0. Cos A 0. So A is cos A is 90 degree. This one is correct option. Our next problem. In a triangle ABC, B, small b is equal to root 3. Small c is 1. And capital A is equal to 30 degree. Excuse me. A is equal to 30 degree. Then largest angle of the triangle is, options are 60 degree, 135 degree, 120 degree and 90 degree. So only one relation is given here between sides, that is two sides are given, one angle is given. So we have to find the greatest angle of the triangle. So from here, if you use the cosine formula for angle A, the cos A will be b square plus c square minus a square divided by 2bc. Cos 30 degree is root 3 by 2 is equal to b square means 3 plus c square is 1 minus a square divided by 2 into bc. B is root 3, c is 1. 2 cancels, is root 3. Root 3 together is 3 is equal to 4 minus a square. A square is equal to 1. A is simply 1, not plus minus 1. A is equal to 1. Side length is positive. Now we get three sides. We already, these two are given, and we obtain small value of small a. All three sides are known. And we have to find the maximum angle, greatest angle of the triangle. Now, it is, you see, isosceles. A is 1, C is 1. These two sides are same. Opposite angles are also same. So, this is greater than this and that. So, its opposite angle, that is B, is the greatest angle. Now, use sine formula. B by sine B is equal to C by A by sine A, because all are known. B is root 3 by sine B is equal to A means 1 by sine 30 degree. So sine B, sine 30 degree is half, root 3 into half is equal to, sine B is equal to this. So it is equal to sine 60 degree. But answer is not that. Answer is 120 degree. Oh. B by sine B, A by, okay. B is root 3 by sine B is equal to 1 by sine 30 degree. A is 30. So sine B is equal to root 3 into sine 30 degree. Sine 30 degree is half. So sine B is equal to root 3 by 2, sine 60. So B is 60 degree. Okay, B is 60 degree. Maximum largest angle is 60 degree. That's our next problem. In triangle ABC, given that cos A is equal to sine B by 2 sine C, then which one is true? First option, A is equal to B is equal to C. That is equilateral triangle. Number 2, A is equal to C. Number 3, B is equal to C. Number 4, A is equal to B. These are the options. That is, now you see, all results are in terms of sides, side. So try to convert all these things in terms of sides. Cos A, it is actually B square plus C square minus A square by 2BC. Sin B is A by 2R. Sin B is B by 2R. So it is B by 2R by 2 into sin C means C by 2R. These 2R's will cancel. The 2 cancel, C cancel. So we get B square plus C square is equal to minus A square is equal to B square. So B square cancels. So C square is equal to A square. The A is equal to C. Not plus by minus because sides cannot be negative. So A is equal to C. So option B is correct. Now our next problem. A flag is standing vertically on a tower of height h. On a point at a distance a from the foot of the tower, the flag and the tower subtend equal angles. The height of the flag is. It means it is actually problem is like that. So this is a tower, and at the top of this one flag is there. So number one, this is tower, this is flag. At a distance a from the foot of the tower, this is A. From this point, the tower and the flag subtend same angle. Let it be alpha. This is alpha, this is also alpha. So then we have to find the height of the flag. Suppose height of the flag is h. Let height of the tower is b, and that one is a. It is given. B also given, and we have to find the height of the flag. Options are there. B into number 1, B into a square plus b square by a square minus b square. Second option is a into a square minus b square. Third option, b into a square minus b square by a square plus b square. And fourth option is a into a square plus b square by a square minus b square. These are the four options. Achha, this problem is from height and distance. So it is given in JEE Main Advance and in state level joint entrance also. So I tell you, this type of problems are very simple. Mind that. So given thing, one tower, one flag is over there, and this is foot of the tower. At a distance a from the foot, one point is located where the angle from this point, the angle between the tower and angle with the height of the flag, same angle. Achha, suppose this is O, this point is A, this point is capital B. We have to find H. Value of H is this or that. So in triangle ABC, AB, A, this is C, say AOC. This is a right angle triangle. This is base. This is angle A. This is height. So we get tan alpha is equal to B by A. Tan alpha is B divided height by base. Tan of 2 alpha. This together is 2 alpha. This angle 2 alpha. Its height is BO and base is A. Tan 2 alpha is equal to B plus H divided by A. Now tan 2 alpha can be expressed in terms of tan alpha. Then I think answer will be available. So B plus H divided by A is equal to tan 2 alpha means 2 tan alpha by 1 minus tan square alpha is equal to 2 tan alpha 2B by A by 2 tan alpha 1 minus B square by A square multiply through by A square here and there also. 2AB by A square minus B square. Now from this equation B plus H by A is equal to that. Here only unknown quantity is H. A, B are given here. So try to solve it. So B plus H is equal to this that. So multiplying by A 2A square B divided by A square minus B square. So H is equal to H. We want H. 2A square B by A square minus B square minus B. So that 2A square B minus A square B plus B cube divided by A square minus B square. So that it is equal to, they together is A square B plus B cube divided by A square minus B square. So taking B common, A square plus B square by A square minus B square. So first and b common, so b into a square plus b square by that. So option A is correct. My next problem. The sides of a triangle are in the ratio 1 is to, just 1 minute, 1 is to root 3 is to 2. Then angles are in the ratio. For any triangle, ratio of the sides is this. To find ratio of the angles, and options are 1 is to 3 is to 5, second one 2 is to 3 is to 1, 1 is to 2 is to 3, and 3 is to 2 is to 1. This. Given that sides are in the ratio, this is to that. So sides are of, say, k, root 3k, and 2k. Cos C is equal to a square plus b square minus c square, that is k square, plus 3k square minus 4k square divided by 2k into root 3k. But this is 4k square minus 4k square is equal to 0. So cos C is equal to 0. Therefore, C is equal to 90 degree. We get C is equal to 90 degree. So then find one more. We know this formula, sine formula, A by sine A is equal to C by sine C. I choose this formula because from sine formula we take the ratio first and third, because this sine C is known and we try to find A, any other. We can start from there also. Root 3 by b by sine B from there also. So it is equal to k by sine A. C. C means 2 by sine 90 degree. That is 2k. K cancels. So we get sine A. Sine A is equal to, this is 1, this is 2. So it is half. Sine 30. So we get A is equal to 30 degree, C is equal to 90 degree, they together is 120. So B, angle B is pi minus 120, that is 60 degree. So ratio of the angles is 1 is to 2 is to 3. This is correct option. Okay, next problem. Now this problem is, in triangle ABC, sine A sine B is equal to AB by C square. Then triangle is Then the triangle is equilateral, then isosceles, then obtuse, then next one right angled. So for a triangle ABC, one information is given: sine A, sine B is equal to that. They are all in terms of sides and all in terms of angles. We have to find what type of triangle is. So use sine formula. Sine A, you see sine A is equal to A by 2R. So it is A by 2R into sine B is B by 2R is equal to AB by C square. So clearly AB cancels and C square is equal to 4R square. So C is equal to 2R, not plus minus. C is equal to 2R. Then C by sine C is equal to 2R, like that. So C is equal to, C itself is 2R. And sine C is equal to 1. C is equal to 90 degree. It is a right angle triangle. This option is correct. Yes. Okay. Today is up to this. Next day we discuss some more problems. Thank you.